Hello everyone, welcome to my channel NomadsBits. In this video, I'm going to give you an overview about what is an integrated circuits, how it's made, and what are types of integrated circuits. So let's start it. So an integrated circuit is a tiny chip made from a material called silicon that holds a complete electronic circuit inside it. It contains transistors, resistors, capacitors, and wires, and all four formed inside the chip itself. So there's a chip which contains transistors, resistors, capacitors, and wire, and they are fitted into a single chip, and that chip is known as integrated circuits. So how is it possible? The answer lies in technology called photolithography and semiconductor fabrication. Here's how it's done in a simplified way. Start with the silicon wafer, which is also known as base. And what is silicon? Silicon is a material which is used to making a semiconductor. And what is a semiconductor? Semiconductor is a material or is a device that is you that the conductivity lies between of insulator and conductor. So silicon semiconductor is a device that the conductivity to conduct electricity is between some of insulator and conductor. So a thin flat slice of pure silicon is used as the base. Silicon is a semiconductor, meaning it can act like a conductor or an insulator depending how we treat it. And photolithography, like printing a circuit on a base, like on a silicon base. A light sensitive material called photoresist is applied on the silicon. Then a circuit pattern marks is projected onto the wafer using ultraviolet light. This pattern defines where each component, like transistors, resistors, wires, should go. So we take a silicon wafer as a base, and at that base we print a whole circuit with the use of ultraviolet light. So moving on forward, the next step is doping and layering to create components. Transistors main switch of the circuits. By adding special chemicals called dopants into specific areas, we create an n-type and p-type region to form a transistors. A transistor is made by carefully arranging these regions into layers: collector, base, emitter, and source gate, depending on type. Second, resistors. Resistors are made by using certain types of doped silicons or polysilicons with specific resistance values. These values is controlled by the length and width of the material. Capacitor are made by using very thin insulating layer dielectric between two connecting plates, metal layers or doped silicon. They are very thin and layer vertically. So this is our third step to create actual components of the circuits like transistors, resistors, and capacitor. Transistors, as we discussed, transistors are made by using dopants. Resistors are made by using certain types of doped silicons or polysilicons with specific resistance values. Capacitors are made by placing very thin insulating layer dielectric between two connecting plates. So yeah, moving on to forward, we have another step is metal layer, connecting everything. Once all components are formed, like once resistors, transistors, capacitors are formed, then metal layers, thin metal layers, usually aluminum or copper, are added on top to act like wires, connecting transistors, resistors, and capacitor together. These are called interconnects. Repeats in layer. Multiple layers of circuitry are created on top of one another with insulating material in between. Modern integrated circuits can have dozens of layers, all packed into a chip smaller than your fingernail. So the final results are a complete circuit with millions to billions of components like transistors, resistors, and capacitor, all fit into a tiny black chip you see in electronics. This is how an integrated circuit built. Now the question is, how many types of integrated circuits are there? As we know, an integrated circuit is a general term for any chip that contains a combination of transistors, resistors, capacitor, diodes, and other components, all built on a tiny piece of silicon. So integrated circuits can perform logical operations like signal amplification, memory storage, timing and control, communication tasks, power management. So IC is the category that CPU IC is a category. So the CPU is an integrated circuit, but it is one of the most advanced and complex types of integrated circuits. Hence, there are various types of integrated circuits, and CPU is one of them example of integrated circuits. So we categorize integrated circuits on based on function, based on complexity, and based on packaging, and based on application. So first we see the types of computer that lies in category based on function. First is digital integrated circuits. Work with binary zeros and one found in computers, logic circuits, microcontroller, etc. Examples are microprocessor, CPU, microcontroller, memory integrated circuits, RAM, ROM, logic gates and or not, timers, flip-flops, counters. These are the digital integrated circuit. Analog integrated circuits handle continuous signals like voltages that vary smoothly using audio, sensors, amplifiers, etc. And examples are operational amplifier, also known as op amps, voltage regulators, analog filters, comparators. And the third is mixed signal integrated circuits, combine both analog and digital functions in one chip. Example, analog to digital converter ADC, digital to analog converter DAC, sensor interface chips, microcontroller with built-in ADC DAC. Now the second category is based on complexity. So complexity, SSI. First is SSI, small scale integration, and this SSI complexity contains 10 to 100 transistors, few logic gates, basic circuits. Example are basic logic gates IC 7400 series. Medium scale integration. In this integration, we use 100 to 1000 transistors. Examples are multiplexers, counter, simple processor. And in large scale integration, we use 1000 to 100,000 transistors. Example are basic microprocessor like Intel 8085, and fourth is very large scale integration. In this complexity, we use 100,000 to billions of transistors. An example, and this complexity we use in modern CPUs, GPUs, SoCs, system on chip. And the last one is ultra large scale integration, even beyond billions of transistors found in latest generation processors like Apple M1 and AMD Ryzen. These use this type of this Apple M1 chip and AMD Ryzen chip use this complexity, that is ultra large scale integration. And the third category is based on packaging. So first is DIP, dual inline package, through hole mounting with 2 rows of pins. As you can see in the diagram, this basically we build the components. We divide the integrated circuits on based on packaging, like how we package the circuits all together. So as you can see, there is pin on one side and another side. So this is called DIP, dual inline package. The second one is SIP, single inline package. On one row of pin, there is only one row of pin. In dual inline package, there's 2 rows of pin, which is one side and another in this side. And the third one is QFP, quad flat package, flat square rectangle integrated circuits with pin on all sides. So as you can see, there's pin in on side, which is known as QFP, the QFP packaging. And at last is we have BGA, ball grid array, used in modern CPUs, GPUs, has balls instead of pins for dense mounting. As you can see, these are the balls which package under the microprocessor. And the third category is based on application. Integrated type microprocessor application examples are main processor of computer, microcontroller used in embedded systems, memory integrated circuits, RAM, ROM, flow, flash storage, sensor integrated circuit, temperature, motion, etc. Power IC, voltage regulation, communication integrated circuits, Wi-Fi, Bluetooth, Internet, Ethernet, audio IC, amplifiers, codecs, timer IC, timing circuits. So these are the categories that we divide. So these are the types of integrated circuit that we divide on these categories. Now let's see which type of integrated circuits that we are used in third generation computer era. In third generation computer, we use digital integrated circuits, which is used for logic circuits like AND or NOT, flip-flops, counter, etc. So third generation computers mainly use digital integrated circuits to build logic units and control systems. By complexity, we use SSI and MSI, which is also known as small scale integration and medium scale integration. And in a small scale integration, as we discussed earlier, the integrated circuits uses 100 to 10 to 100 transistors used for logic gates, and in MSI 100 to 1000 transistors used for adders, counters, etc. So most third generation machines use SSI, and later models starting using MSI integrated circuit to reduce circuit board complexity. And by packaging, we use dual inline package and single inline package. There is no concept like QFP, BGA, because these types of packaging used in mostly fourth generation computer, and in third generation computer we use mostly DIP and SIP packaging. And as we know that DIP black rectangular chip with 2 rows of pin, and in SIP used for smaller or simpler integrated circuits which have only 1 row of pins. So the ICs were mounted onto circuit board using through-hole technology, mostly in DIP packaging. The CPU itself was not a single integrated circuit yet in early third generation. Instead, the CPU was often built using multiple SSI, MSI ICs mounted on boards. Full CPUs on a single chip microprocessor came in fourth generation, starting with Intel 4004, which is built in 1971. So these are the classification of integrated circuits that are used in third generation computer. So yeah, that's it for today. Thank you.